Good afternoon, folks. Well, I say good afternoon. Good afternoon if you're in Europe, good lunchtime if you're in Western Europe, and good morning to our next speaker, Mary Grygleski, who's joining us from Chicago, I believe.
Yes, that's correct. So, it's 6 a.m.
Welcome to Build Stuff, Mary. It's fantastic to have you here. So to all the folks out there, we got about 85 people watching on the stream. To all of you folks in Vilnius, in the cinema, sitting there with your free popcorn watching, hello. Great to see all of you as well. And now, please welcome to our Jupyter virtual stage, telling us all about exploring stateful microservices in the cloud native world, Mary Grygleski.
Thank you, Dylan. Thank you so much. And thank you again to Build Stuff. It's just amazing. I wish I could come, but I've been to another conference in Vilnius too. But I spoke here last year as well. So I was really happy and honored to be back. And thank you again for coming to my talk. Today, I'll be talking about, stateful microservices in the cloud native world. And I thank you too to Dylan for having introduced me already. So let me kind of move forward, although I do have a quick slide just to kind of talk about what I'm working on. So I'm essentially doing open source Java, but specifically for open source side of WebSphere and Liberty, which are OpenLiberty, Eclipse Microprofile, the microservices framework, and also Jakarta EE, which is the Java de facto standard for the enterprise Java. And I'm also a DevRel engineer. I have over 25 years of software engineering experience, and I've worked with many things. And now I'm kind of working with more Java right now, open source, cloud, and DevOps. I'm also president of the Chicago Java Users Group, and also very active tech community co-organizers, also active church volunteer. So without further ado, let me start. So thank you for coming to my talk. So yes, I'll be talking about microservices. So, but from a different angle. So here I'm going to be talking about is stateful and versus stateless. So and I'm not sure how many folks have already been working, kind of specifically focusing on stateful. But I'm kind of assuming most of you, if you're already working with cloud native, then no doubt then you're already working with stateless, because that's what cloud native essentially is like promoting, right? Cloud native applications running on the cloud, the current modern cloud infrastructure, Kubernetes, all these, they're supposed to be all stateless. So this talk is kind of explore how do we then handle stateful data. But with that too, let me also start with some kind of a introduction, because maybe if you're new to here, I wanted to kind of make sure everybody is start with on the same page. So pardon me if you're already aware of some of these things. But the thing is too, I like to make it a little more fun. Sometimes these topics are like so dry, it's kind of, okay, you do this, ABC, all these protocol, but let's kind of like discuss it from a different angle. So here I have a picture of Finding Nemo. So if you are into cartoons, if you have children, I'm sure you have seen this movie. It's really cute, right? So, and I'm using it as an illustration. Now, it's just a quick thing, right? To kind of make sure you are aware of the story. So little fish Nemo was lost in the ocean, and father, right, Marlin, daddy Marlin was kind of go out searching for little Nemo. And, while he was swimming around the big ocean, wide ocean, then he ran into this fish, blue fish, Dory. Dory, if you watch the movie, you know that, or watch the cartoon, she's like a happy-go-lucky, doesn't remember anything and just jump on anything like that. Whereas Marlin would be like, always be, on guard. And then he would be seeing Dory swimming towards a bunch of jellyfish because they look so pretty. And then Dory was like, okay, I'm kind of ready to kind of join these jellyfish and jumping on them. But Marlin said, wait, don't do it, because jellyfish will sting you, right? And like that. So as you can see, you can probably see where I'm getting to. Why am I using this example? Even though it's not like, it's kind of from a fun way, it's not exactly what it is. But I think on the concept level, you see where I'm getting at. Because Dory is this forgetful fish and doesn't carry any memory essentially with her, just do things. Whereas Marlin would be always worrying about something and remember something, and whatever he does, he will remember what he's supposed to be doing on all these things that's associated with what he's going to do. So you can see, if you compare Marlin, it would take a lot more time for him to do something, but not a whole lot. But as compared with Dory just jump on anything. So it's a lot more lighter, right? More agile, more like happy-go-lucky, I go do things kind of thing. So that's why I'm kind of using it as an example, because it's just illustrating, stateless kind of processing too is meant to be more lightweight, more like, no baggage. And when you do something, you're kind of pretty fast and from that perspective. So performance-wise too is a lot faster. And that's why cloud native computing is adopting that approach to doing different things, many things, but microservices too. Yes, we're dealing with stateless processing. So let's take a look. Computing life used to be much simpler, right? So let's kind of take a quick look at the definition. Stateless computing. So as we can hear, right, it is kind of everywhere now in the cloud. We have like functional style of programming or like lambdas. And I was just talking with Dylan before this about like serverless, right? Everything is kind of lighter. You really don't have much of a baggage. So stateless computing. So it really means it's a communication protocol, fundamental meaning, right? That does not retain any session information. So you don't have to like worry about recording all of your kind of things that are happening, the state of your application, the data and everything. Between transactions, you probably don't even care, just do things. And so as a result, your architecture, design, implementation, everything's much simpler, because if you want to scale your system, it's just a matter of spinning up another, let's say in Kubernetes, you just spin up another node to kind of handle all of your processing without having had to kind of look up and see, well, how do I kind of make sure, I set up this component or this worker node with all of the things that's necessary. It's just a lot faster. It's just spinning it up, taking default, for example, default configuration, rather than taking, looking around to see, well, what is it, the state of everybody is, and then I try to initialize, right, like that. So likewise, if you have any system failure and all that too, you want to recover from your system, from system failure, also it's easier. It's just a matter of spinning up another node, spinning up another worker node, spinning up another component, as an example. But realistically, we live in a stateful world. We need to be remembering things. We need to kind of have some kind of context, what you're doing. And besides too, a lot of times, we're dealing with money. So especially in a transactional type of environment, it's absolutely important that we track every single movement of your data, of all of these things. You need to be tracking it. So then that's where like stateful. Oops, why is it not moving? Okay, here we go. And that's why this is where like stateful computing kind of come into the picture. Interestingly too, I haven't been noticing as many talks, in this area, but it's actually absolutely important. I'd say, over 95% even, right? Or even close to 99%, you have to have some sort of way of keeping track of your data during your processing, in your code, right? So essentially, stateful computing then is completely opposite of stateless computing. You want to make sure the state of the data get recorded at every step across all transactions. And then if you want to scale the system, as a result, right, design, implementation, everything's more complex, and you want to recover from a system failure, then you have to make sure, okay, when we spin up another worker node in the cluster, for example, you want to make sure that get initialized to what everybody is, in your whole cluster. So as a result, yes, the performance-wise, right, it's just less agile. Everything takes more time. If you have to read some files and kind of initialize some components, it costs time and money, right? So that's stateful computing. So let's take a look into statefulness in the cloudless states. I call it cloudless, it's before the clouds. So how do we do that, right? And even though, yes, there's cloud native now, stateless and everything, but it had the systems has been existing throughout time, the computing time. So especially during client server systems kind of era, I'd say like in the 90s or like early millennial, 2000, that's when kind of the client systems, client server systems started kind of happening, right? Popping up everywhere. So how do we handle statefulness? So essentially too, for a lot of database application, we see that their database itself it's built into the way they handle transactions. I think it has to, because you're dealing with data. So if you, let's say using SQL, right, you have to do select and then do updates and delete and insert all of these, they are transactions. So anytime you do something, then you usually too, you would let the database manage all of the transaction. But there's also like user level transaction, right? You can basically say, well, I don't want the database to do it for me. You can then kind of manage your own transactions. But of course too, then it will be more complicated. You have to be managing the transactions. And sometimes, if it's doing like simple things like, okay, I want to update or insert, it's simple enough. You just say, okay, I start the transaction, do an update, and then do a select, whatever it is, and then I'm done. And when you're done, then essentially you do a commit, right? If everything is all good, you commit. If it's not good, you do a rollback. So that's how kind of database kind of way of handling transaction, kind of basic concepts. Now, we live in a complicated world. A lot of times too, it's not just like dealing with one database. You could have an e-commerce system that have components that are living in many different, or I should say, even during the monoliths time too, you can have an application maybe interacting with multiple databases, because one database, let's say, is a DB2. IBM DB2, right? You can be handling all the order entries, and then you can have an Oracle database that handle your customer information, right? And all of these things. But so you can see where it's leading to, because if you're doing an e-commerce system, then most likely then you're touching all of these databases within your larger application ecosystem. So that's when how we do it is essentially relying on this protocol called two-phase commit protocol. And what it does is essentially too, it relies on a middleman, a coordinator. So that's what it is, that we have a two-phase commit protocol broker kind of middleman, right? Is it called broker? I kind of sometimes like working with all the messaging systems, and that's how they're like broker, but the functionality concept is the same. You rely on sort of a coordinator in there. That's right, two-phase commit coordinator. So giving an example, same thing, if you do an order entry system, let's say, right, I have my coordinator, and then I'll be saying, okay, this order entry comes in and it goes through all the processing, but the coordinator's job is essentially to oversee everything, making sure all of your database is doing its job. So everybody has their own piece of functionality, maybe managing the order entry, one is managing the customer service, then essentially too, when you're ready to commit, so it's the coordinator's job to first say, yeah, are you ready? And then, kind of one database would say, okay, I'm ready. So then this coordinator will collect, so to speak, collect all the votes, right, from each individual databases. Then when I'm done with this, I ask another database. And by the time you go through, in a hypothetical situation, you can have 10, 20 different databases. When it's all done, then the coordinator will look at everybody and says, okay, you go commit, and then tell everybody to commit. So as you can see, it is a very good protocol in some sense, because you make sure you have the coordinator to coordinate everything. However, the back kind of, or I can say, is a bit of a disadvantage, is that you can tell it is not fast, right? It has to wait. And the synchronous kind of nature is not about asynchronous processing either. You basically, everybody is like waiting for the leader, this coordinator, to kind of ask everybody, then what about the network goes down, right? We cannot kind of rely on the network to be reliable all the time. So in that time, in that case, if the network goes down, then all of a sudden you lost connection to your coordinator, then you still are waiting. Let's say I'm like, in the 6th database, still waiting for my coordinator to give instructions, then that would be an issue. So very often too, in this scenario, two-phase commit will work, but it just kind of have this, it suffer from this thing from being a bit of a performance kind of issue in here. So yeah, so that's why too, I think in nowadays too, we have different ways of doing things. So we'll take a look into it. I can kind of go on days and talking about this, because I've worked a bit with two-phase commit. But anyway, so that's how kind of the history, looking back, this is how it's being done. And two-phase commit protocol is still being used. And in fact, in today's database, like let's say using sharding, some of them are actually still using two-phase commit behind the scenes too. So, okay, so that's that. And then in Java, in here, right, this talk primarily focusing on having examples using Java. So, and again, these are all conceptual stuff. You can use any other languages to do this kind of processing too. But here, let's talk about Java. So in Java, we have enterprise Java. So there's enterprise Java beans. If you're familiar with Java, then there's also EJB, right? EJB is within the Java Enterprise Edition specification. So now it's called Jakarta EE. So there's a stateful EJB. So stateful EJB also has different kinds. There are stateful, stateless session, or actually I should say, stateless EJB, and then there's also stateful session EJB. So what it does is that essentially, let's say you are dealing with a request, like a client coming in, it carries with it, a bunch of requests. Then essentially too, the state of your data, everything will be kept alive, during the session. But once the session goes away, if your request session goes away, then all the data just get thrown away. It won't be saved. So that's more like the stateful session beans. Now, if you do want to save your data, then you want to use entity beans. And those are kind of EJB, but they're entity beans because it gets mapped to your persistence layer behind the scenes. It can be database or any kind of maybe storage systems too. So that's how Java does it. And then also on the web application side, then we have servlets. So for servlets, we make use of HTTP session that kind of help you to maintain all of your data during an HTTP session. So that's Java in a nutshell. And then the next thing is too, we also can make use of client side, like caching of server responses, all of these things. So I'm sure too, if you're familiar then with working with web technology, you're familiar then with cookie-based kind of authentication. So that's a way of kind of keeping the state, because you're having the cookie. By having a cookie, then you can essentially to work with your server side to kind of keep this session information alive is by the use of session data through the use of cookies. Now, there's also then token-based authentication, JSON, web token, or JOT, right? They call it JOT. So you can also use JWT as well. Now, the difference is that, excuse me, cookie-based authentication tends to be in some ways, right, it carries with it the session information, session ID, whenever you need to have a request, then it goes over to the server side and present this ID, session ID. So the server would have to authenticate. Once you're authenticated, then basically it's then telling the client to go back, to fetch all the data that's needed, and then carry with it this payload, a second trip back and submit all of your requests to your server side. Whereas with JSON web token, then it's a lot lighter. Well, I shouldn't say lighter, it'll faster, because then your JSON web token also carries with it the session ID and also the payload. So then you don't need to make a separate trip back to your server and get and fetch the data the second time over the network. So that's a bit of a differences between the two, kind of in a nutshell. And now then let's kind of move on to talking about stateful microservices in the cloud native environments. So now again, I kind of brought up the fact that cloud native computing is all about stateless containers, all of these. So how do we do managing all of this state, right? But let's kind of also first take a look into cloud native computing. Now, if I'm in person, I will be asking how many of you are already working with cloud native, but I have to assume that just from previous kind of experience talking at different conferences, I understand that not everybody has worked with cloud native type of technology yet, or maybe you are already still kind of assessing and evaluating. So let me give a bit of a background information. So cloud native computing, to me, in my mind too, I think of it more like an extension to cloud computing. So what it does, its purpose is basically to allow applications to run in the cloud, in the modern cloud computing infrastructure. So that's cloud native. So everything too is essentially you want to build to leverage on your cloud computing infrastructure. And primarily too, in today's world, we're talking about containers, and then naturally too, Kubernetes come into the picture. So you're like that. So essentially too, right? The goals, well, actually I should touch upon too, is that it was actually Netflix that coined the term cloud native. And that was like in the early 2010s. And they essentially, right, they dealing with movie data, media data in huge volumes. If you have to be streaming all of your, movies to your customers, so many, around the world too, maybe, I think. So at least in the US, it's very popular, Netflix, this platform. So actually Netflix was the early kind of ones, among all companies that are kind of leveraging on the cloud to do their job. So they want to make sure that the cloud native, the application can run on, the cloud in a highly available manner. very scalable and very performant. So they coined the term cloud native and at a conference, in fact, and that's how this term came to being. And in fact, if you look at 3 of these bullet points, right, they are high availability, scalability, and performance. These are kind of, it shares the same goals as like a reactive systems. Now, reactive systems too will be slightly different, but I'll touch upon it in a little bit too. So, but let's kind of go take a look further. So for cloud native systems, very often too, when we talk about it too, there's some, we would bring up this 12-factor application guiding principle. And in fact, it is kind of becoming the standard of guiding you as to, how do you do cloud native application. So this is actually a methodology. It's a set of guidelines or best practices for portable and resilient applications that are well suited for the cloud environments. So, and it's a methodology that was drafted up by developers at Heroku. And then one of the factors, right, of these 12 factors indicates the need for self-contained services, which are to be deployed as stateless processes. So microservices architecture so far is the one that can satisfy such a requirement. So that's why you often when you see the word cloud native, very often you see also essentially people are doing cloud microservices because it really fits very well into this 12-factor application guideline. The nice thing also about it is that microservices doesn't dictate what kind of tools or libraries that you need to use, right? Your applications, you can use anything, but as long as you follow these 12 factors. So let me kind of very quickly kind of point it out, right? You can see it's essentially doing application in its kind of full cycle, every aspect of it that touches, started off from your source code, right? It's kind of really in any software system, the code itself is the key to everything. So your code base is very important. You want to be able to track it in some sort of revision control. And these days are mostly Git, and then you can be having it in GitHub or GitLab or any kind of repository platform that can handle Git. So, and then anyway, then the second thing is like dealing with dependencies. So you want to make sure that your dependencies within your system, they are being explicitly declared. And also you want to isolate all of these dependencies. So everything is kind of loosely coupled and it just ended up being able to be managed in a much more agile fashion too. And then configuration too, you want to store the configuration in the environment. And then backing services, you want to treat any kind of backing services, such as like a database, any logging of these, they are attached resources. So you don't have to like have things again, not tightly coupled is the key. And then build, release, run to, essentially, you want to separate out all of the build and run stages. And this is where DevOps, the practice of DevOps, even though DevOps itself is more, I think, of a conceptual and culture and guidelines and everything, but on the, kind of operational side, and that's what it is, you want to make sure that, your build, they're set up to be continuously building. Any changes comes in, right? Continuous integration, continuous deployment, all of these are really the DevOps aspect of the 12 factor. And then for processes too, you want to make sure all of your apps are being executed as one or more stateless processes. So we already talked about it. That's the microservices approach. Then there's also port binding. You want to make sure, you be able to export all of these services via port binding too. And concurrency too. You want to make sure, you can scale out via the process model. So for example, to like the scalability aspect, right? Let's say in a Kubernetes type of container orchestration type of environment, you want to be able to have things kind of happening all at once. They get kind of the concurrency processing side is very important. If you want to scale it out, it's easy to add another node into your cluster, for example. And then disposability is dealing with, fast startup and graceful shutdown. So in that case too, like a serverless approach will be much better because it allows for essentially your microservices, things to kind of start up in your server much faster. So you want to have that kind of capability. And then dev prod parities. So you want to make sure that you want to keep all of your development, staging, certification, production, pre-production, all of your environments as similar as possible, because you want to be to be able to, let's say you want to run tests, you want to make sure they are similar. So you want to make sure that aspect is being kept, so that's why you use containers. It's just a lot easier to do that. And then there are also logging too. So for logging, you want to treat it as event streams, and that will be a separate topic to talk about this whole aspect. And then admin processes too. You want to make sure they are all one-off processes too, not attached to your directly attaching, kind of any loosely coupled or tightly coupled aspect to your microservices. So that's the 12-factor application. So now then, how do we preserve state across sessions and transactions and network boundaries? We're talking about serverless. So let's kind of take a look too. Then there are techniques and mechanisms, which I already kind of extensively kind of went over, right? Just now, within this time, I talk about the cache, right? And we still use that mechanism to leverage on caching. Then there's database style transactions, and database are still heavily being used, right? Even though now maybe we're using like NoSQL rather than, kind of relational database. You can actually, some of these key value pair NoSQL database can also be used as a caching kind of mechanism. For example, like CouchDB, Couchbase, or MongoDB, all of these. The Redis also is a good kind of provides you with good caching kind of mechanism. And then again, database style transactions, the cookies too. We still leverage on a lot of cookies, and you also take a look too into Kubernetes. It has this cookie kind of sticky cookie concept too. So we'll take a look. And then sessions and tokens. So these are like the various techniques and mechanisms we can kind of leverage on within your application environment to help with preserving state. So now then, let's take a look then in a cloud native infrastructure. We're talking about containers. We're talking about Kubernetes. These are everywhere. And of course, there are other kinds of container orchestration, but I would just kind of highlight Kubernetes because it's just the majority of systems are using Kubernetes now, or variants of Kubernetes, such as like OpenShift. That's where I work for, right? With IBM, we have Red Hat. There's also this value enhanced, OpenShift Kubernetes environment. So, but they work kind of in similarly to like all of the conceptual kind of pieces. So let's take a look in Kubernetes too. There's also this concept called leader election. So essentially too, this is a built-in kind of algorithms within Kubernetes that will handle, as you can see, right? If we're dealing with multiple components that are replicated within your cluster, you want to have essentially a leader, so to speak, right, to come out. Even though you say, okay, I can be self-driven, everybody, each of the components, but you do want to have, so to speak, like a leader to kind of make the decisions, or who is going to do the work and all of these things. So these are essentially being handled by the algorithms that's built in. You can actually use things, for example, like external capabilities, such as like Zookeeper, right? Apache Zookeeper, so that manage like multi-cluster environments, managing distributed systems well too. But the thing is too, you don't necessarily have to use any external things, because Kubernetes itself, it has etc etcd here, etcd itself, that this it's already having its own way of dealing with kind of leader election. Let me kind of give you an example why that's important. Let's say if you're in an e-commerce environment, you have different components, right? Everything is being replicated. And let's say you have a payment component. So you have like duplicated, components that are handling the same thing. They're replicated in your system. Now, when there's a payment that needs to happen, let's say let's say even just like you have two of the same payment component that's responsible for actually contacting your authorizing payment system to the credit card company. Now, when your request comes and you need to submit the payment, you don't want both of the same component to actually, submit the payment or kind of like, credit your payment system of your customer, right? So you want to have one of them doing the job. So this is why leader election is very important. You want to make sure that only one, out of your pool of clusters of all of the components, only one is in charge of making the payment, right? So that's why it's important. So that's that. And then, okay, let's kind of move on to the next thing, which is stateful sets. So in Kubernetes too, it has a concept or features called stateful sets. So essentially too, stateful sets, as the name implies, it helps with managing the state of the data of all of your components, right, on more of the infrastructure level. So for example, you have, in any given point in time in your system, you have Kubernetes running that manages all of these worker nodes. They are some of them, they are a cluster of similar nodes waiting for requests and all of these things. And you want to be able to, at any given point in time too, you can be updating these components, right, up and down, or spinning it up and down and all of these things. So Kubernetes has this feature of allowing, it manages essentially the state of this data, making sure that similar cluster of nodes that they all stay, with this, they're all being synced up, so to speak, correctly. So there's this stateful sets kind of feature. And also, if anytime you update your components, it's also being tracked. So Kubernetes also kind of essentially it manages all of these components and nodes within your ecosystem. So kind of in a nutshell, that's what it is. And now then let's move on to persistent volume. So persistent volume essentially is dealing more with the storage level. So how do you actually manage, right? Now you get to the level of, it's actually more like the storage that are with your physical volume of your disk and everything. So in Kubernetes too, you can actually manage, right? Sometimes your logical assignment of all of your disk. So you kind of make use of this persistent volume capability. And for clients too, you can do persistent volume request, for example, to kind of like request, the actual volume to be added, let's say, to some components for managing all of your data. So that's that. And then there's also this cookie. I earlier talked about some mechanisms within Kubernetes too. There are cookie and session affinity, what is called like sticky session capability. So what it helps with it is that, let's say, right, you have a pool of different, kind of same components running in a cluster, and some requests is coming in. And then let's say one of these will answer the request and starting to do its job. So rather than, having another, let's say the same client coming in again to ask for work to be done, you want to maybe pick the same node, right, that is already handling the request for this client. Why? Because, for obvious reason, it will be a lot faster. You don't need to reinitialize everything, that's needed, right, on your node to handle the request. So that's essentially what it is. That's why it's called sticky session, because then you basically kind of this stickiness, then that it knows its client, the client that's coming in. I can essentially service the same client. So then you don't need to spin up another, kind of node in your cluster. And then in that case, you have to initialize and everything. So that's what the cookie session affinity is, that it's also built into Kubernetes as well. So these are like how Kubernetes can handle things on the infrastructure kind of perspective. Now, let's then take a look, right? From the programming perspective, there's some interesting programming design patterns that I want to bring up, which is the Saga pattern. So Saga, as the name implies, it's dealing with long-running transactions. So these are for transactions that are spanning across multiple services and essentially too in a large distributed system, like I mentioned earlier about a system in which you can have different databases. You definitely need a mechanism of coordinating all of these actions and wanting to also, most importantly too, in this case, making sure the data gets preserved, and because you can be running the microservices here or there, they can be across network boundaries and doesn't have to be on the same server, that type of stuff. So you need this mechanism to handle syncing up all of your data on disparate kind of location or different location of where these microservices are located. So this is where Saga pattern can come into really kind of big help. And the interesting thing about Saga is that, well, first of all, I should say, there are two ways of doing coordination sagas. One is more like a self kind of directed, kind of what you call it. I'll kind of show you the example shortly, but essentially there's this choreography way of doing things, which is leveraging on an event-driven type of mechanism. And then the other way is essentially dealing with orchestration and orchestrator, which actually then brings over here I'm looking into it, long running action. This is kind of a feature capability in the micro profile, the Eclipse Foundation open source project, micro profile. There's also a feature, exactly, that's what it's called, long running action. It's called LRA, just recently got released too, basically in May this year. So essentially it leverages on the Saga interaction pattern. And the interesting thing about Saga is that there's no concept of rollback. So it's unlike a database kind of mechanism. We don't call it a rollback. Essentially, it's a forward strategy. If you do something wrong, rather than saying that, oh, kind of rollback kind of thing, it's basically has a compensation kind of capability in which you compensate for what, should be kind of fixed or kind of rollback. In some ways, I think in some ways the overall effect is like a rollback, but it isn't a rollback because the way it's being done, essentially you have to write another module, which is kind of counterpart to your microservices that will handle compensating for things that have been done. Essentially you want to kind of roll back or kind of fix, make it go back into the original state. That's what it is. But let's then take a look in a quick example. Here it is, right? Today, because this is just a presentation session, and also I'm also starting to try to kind of have effort to start coming together to work on this. So there's no implementation yet, but it's an idea that I have in my mind. It's about a shopping cart. So it's kind of leveraging on the choreography event-driven Saga pattern, but I'll just kind of talk through it quickly. So here, right, if you take a look, this is a simplified order processing system. Let's say you have some order that comes in, right, from a shopping cart, kind of think of it that way. Order comes in, it gets generated. So essentially it's event driven because my order microservices, it's kind of built in to listen for any kind of orders that gets generated. In this case, I'm using a Kafka topic, right? So basically, if an order gets created, then essentially there's a message kind of being produced, from my Kafka kind of producer side. And then in this scenario, my order is a subscriber to this Kafka topic. So then once I get the order, then I kick into high gear, I'll start my work and basically then it does a bunch of things. Of course, there's probably some order database that you need to create your order entry and then set up certain things and collect all of the data in this basket, right? So to speak, what it is and everything. And once it gets created, then you generate another event called, let's say, order created event. So in this case, the inventory check and the credit check microservices then are listening for these events, order created. Once they see order created event, then inventory check will then, gets busy. Let me see, I have this order for, let's say I want 10 bottles of wine, and then I'll go and kind of to my warehouse and make sure that I in fact have 10 bottles there. So it does its job. But too, at the same time, I want to do credit check too, make sure this customers is entering a valid credit card. So the credit check microservices will then contact all its related components, right, that's running. Let's say go into my credit card company payment authorizer to do the credit check first. Now, in this case, they both are doing its job. Then let's say, right, let's pretend it is a sunny day, everything works as expected. Then basically, the inventory check will say, oh, I'm all good. So I also then generate an event called order inventory checked. It's all valid. If not, I'll say, okay, it's not good, right? But in this case, if it's all good, then I generate that event called order inventory checked. And likewise, credit check comes back too, and it says everything's checked. So I have an order credit checked event. So these two then will need to happen before my payment processor will get to work. So once my payment processor receives this, then the payment essentially say, okay, this is all good. Then let me go and do the payment processing and contacting my payment provider, service provider. All of these things does this thing. But also notice too, I have like arrows that kind of point back because actually too, in every stage too of your processing, you will need to also go back to your order and essentially to update the status of your order as well. So over here too, on the left side, I have a bunch of like statuses that can happen. These are state changes for your order. It can be order created, order inventory validated, order credit validated. All of these will kind of be updated in your order microservice. So then you can kind of keep track of where your order is like that. So, okay, so in the meantime too, and you can also see too, I have a note that says there are compensator microservices. And these are essentially what I talk about, the compensation model. You will need to write some compensation kind of logic in order to deal with, let's say, right, I'm doing credit check, but actually theoretically speaking, I haven't really kind of take any money out yet. But let's say I do, right? Maybe sometimes too with credit card company, you could be doing some pre-authorization, some kind of $5 something, right, in the US dollar, right? They kind of you set aside as a pre-authorization check. Let's say I have to write code in which to say, okay, I'll remove this, or maybe I'll credit back, right? Giving you a credit, kind of like that. So in some sense, it's not really rollback, but you're giving back a credit. So you still kind of negate that effect of what happened earlier, kind of like, and like that. So that's an example of kind of a compensator microservices. But it also kind of brings up another question, is that if you write any kind of compensation, that means you are kind of have to tightly couple your components, which kind of a bit kind of goes against the cloud native kind of principle, because then now, if you have any changes in your original microservices, then you also will need to have some ways of telling your compensator microservices to also get updated too. So it's a bit of a linkage in there. So, but that will be left for another discussion. So, but I just wanted to point out. So, okay, so just now too, I talk about payment processor. So when I get to the payment side, then the payment will go off and does its own thing. And if everything is all good, then I'll say, okay, order is paid. And then I also go back to notify my order. It's basically this is order paid status. And then essentially at this point, the shipping processor, for example, could be listening to order paid. So when I'm all paid, then I can then kind of get busy, the shipping. I'll actually go and fetch the items and then notify my shipping delivery to go and deliver, that 10 bottles of wine. So this is, again, a very simple kind of example. And of course, in reality too, you probably will have a lot more components and things to handle, like an order that involves money, right? But this, again, give you some idea. As you can see too, there's no central coordinator, but they are all event driven. So some events happen and then you code it. So then some other microservices are handling, all of these actions that are needed. So that's what it is. So let me then go back to my slides. So as mentioned too, there's also orchestration too. And essentially too, that's what microprofile LRA is. It actually has an orchestrator that helps too. So in this sense, if you're using an orchestrator, then what you have is, rather than all of this event-driven kind of mechanism, you're basically having the coordinator middleman in there to kind of coordinate everything, right? It needs to happen. It's probably, you need to kind of keep track of everything. So for that, I haven't actually worked on that. So that's something I like to be starting to work on and intending to open up, this opportunity for anyone who would like to join the effort too. It's more like a lab kind of exercise. So if you'd like to join, let me know. So. Okay, so now let me then very quickly, because I realize I don't have as much time left. I was hoping to show some code too, but that's okay. Okay, so what about reactive, right? So there are also reactive systems and the reactive manifesto, and essentially too, reactive system shares, the same goal as a cloud native environment, similar, right? I mean, not exactly the same, because reactive systems, we're dealing with streams of data. So that's one aspect that's different. And besides, it also has to honor the reactive manifesto, which is a set of guidelines that guide how a reactive system should be. But the reactive systems essentially is dealing with data as streams, that's the main thing. But cloud native, you don't have to be doing reactive, but if you want to do it, you can also do this, in the reactive fashion, because as you can see, its goals is about responsive systems, very resilient and very elastic scalability, and handle quick recoverability, and also very message driven, loosely coupled type of system. So now I won't have time to go into all of these details. So let me really quickly, maybe like telling you too, because I was hoping to do some lab kind of example too, but if you like, you can visit too. This is OpenLiberty. I want to point out I'm working with OpenLiberty. It's a very agile, I'd say, right? Cloud native ready open source Java framework that's actually built on the proven WebSphere kind of kernel, everything. It's essentially the WebSphere, but the open source side of Liberty, which is Liberty is the sort of, think of it like next generation of WebSphere. So no longer the older fashion Java enterprise app. These are like really cloud native ready apps, and they run on very efficient OpenJ9 JVM as well. So that's quickly want to let you know. So let's kind of take a quick look. You can, I'll be sharing these slides, so there's no need, for you to kind of hurry up and copy it if you miss it too. So let me kind of go over here. And essentially, if you go to openliberty.io, I'd like to invite you to check us out. And there, and you will be wondering, how do I get started? So the nice thing about this is there's also a starter application generator. You generate the template of your application as to what it looks like. Now, I won't have time to kind of demonstrate it, but this should be quite easy. And I wanted to let you know I have a live coding stream on Twitch too every Wednesday, in fact. So if you're interested in joining me there too, and then I will be talking about different things, and I've been talking a lot too about OpenLiberty. So you can also join me there, and there I actually will be doing more coding too. So if you visit this site, get started, and then there's also guides. So this is kind of really nice. If you even just want to be learning cloud native kind of principles, you can actually, I would encourage you to do it. Everything in here are all free. And as you can see, there are like about how many now? We have like 58, exercises you can try. And as you can see, all of these takes short amount of time. So you can take your time to go through these and getting started with OpenLiberty, all of these things. Now, the thing I was hoping to show is persistence. If you go to persistence, there are different ones, right? You can do JPA, the Java Persistence API. We have some example there. Then there's also persisting data with MongoDB. I mentioned about MongoDB being the ones to cache, your information during your session. And then there's this one I was hoping to show is caching HTTP session using JCache and Hazelcast. So this is pretty nice too. So if you go and click on it, and this one actually doesn't have the cloud hosted guides too, but otherwise too, as you can see, here is actually gives you a lot of explanation. It's really easy, and you take your time to work on it. So, and it tells you what is required. So it's really nice, this one. I really want to kind of suggest you do it, but I wanted to kind of give you an example of, not this one, but let's say go back to here. The one thing is that's right. If you look for these that says run in cloud, is essentially you can also do this, and it's hosted on what we call like skills network lab, much like kind of Kolkata's online. So it's really nice. You don't need to install all of these external dependencies too. So I like to encourage all of you to give this a try. And then if you need more information, go to the docs tab. You can see too a lot of things are explained very well in here. All of these about microprofile, Jakarta EE, cloud native, all of these things. So I would like to encourage you to check this out too. And then if you want to kind of have more information, again, I have my Twitch coding stream. So let me kind of go back because I understand its time is running short. So let me kind of, I think Dylan is getting ready to tell me I need to kind of wrap up, but quickly too, I also have another OpenLiberty application in Kubernetes example, a stateful example, using actually Nginx and Kubernetes too. So if you want to take a look in it, it's here in my GitHub repo, and then some more resources and links too. So if you reference my slides, I'll give you all of these things that we have talked about, all the guide sessions, Saga design pattern, microprofile LRA. There's a nice blog article here. And then these are different links to OpenLiberty, microprofile, and Jakarta EE. And these are the guides, the link to the guides that I just showed you. And then some more resources at IBM, developer.ibm.com too. If you want to learn more about cloud, DevOps, cloud native, we have different pages that contains further information for you to look into. And how do I program with Java on IBM Cloud? There's also a very nice kind of tutorial you can follow too. And then there are other links such as Cloud Native Computing Foundation, CNCF, and the 12-factor app, that website. And here, my live stream on Twitch, it's actually today, it's Wednesday, so I'll be doing it later today in my time zone. So if you can join, please join. I think it will be like 9 o'clock, but I'm sure you probably would be tired by the end of the day today. There are also other streams too, so please visit twitch.tv IBM Developer. And then join our expert TV and meetups too. There are kind of regular meetups or kind of sporadic meetups and everything. We have all kinds of things. So please visit it. And my Chicago Java users group, everything is online now. So you're all welcome to join too. I have a consistent meetups too, at least like once a month. And we have sometimes 2 a month too. So. And also, please sign up with the cloud, IBM Cloud. We're giving out like $200 credit if you haven't already done so. And here, so I want to say thank you. I want to kind of keep to the time too. If you want to stay in touch with me, I'm on Discord too. So if you want to join me, this is the link. I will be very happy to answer questions, or you can share with me your project ideas, everything. These are my other links, my Twitter, LinkedIn, GitHub, and dev.to blog site. So with that, thank you very much. I wish I have longer time to talk, but I think I'm going to the Q&A session and we can talk more too. So thank you so much. Thank you, Dylan.
Fantastic stuff, Mary. Thank you very much for that. So we do actually, we got 2 comments in the chat on Pine before we move over to the QA. One of them is just someone saying thank you and saying that they're working on a similar shopping cart application at the moment using RabbitMQ. So there you go, a bit of positive feedback from the online experience. And the second one was a question from Sergey talking about 12 factors, and one of the points in there is about managing dependencies. The question is, do we want to keep most of our libraries and things in Git, as in, do you want to check them in with your code, or is it okay still relying on NuGet, Maven, or whatever package managers exist in your ecosystem? What's your answer there?
Yeah, I think, say for dependencies, right? We're talking about external dependencies. I think I would still keep, basically, yes, Maven or Gradle, all of these. You download to .m2 for Maven, right? And I think that's what I would do. I wouldn't be keeping them in my GitHub repository. And that's what, I think that's how Java is usually handling it. But let's say JavaScript, I think maybe Dylan, you're familiar with JavaScript, right? I think JavaScript, you download into your same, you package it up with your same application. Is that so how it goes? Right?
JavaScript dependency management is you run the script and you check the script in, and then next time you run it, you hope you get the same thing again.
Oh,
there are actually, if anyone is working on JavaScript because package management with NPM has always been a very, very because Java has no runtime. There's no JavaScript equivalent of like the JRE or the .NET Common Language runtime. Everything you either write yourself or you find it on NPM. And so JavaScript projects tend to get very, very big, lots of dependencies very fast. There is a project out there called Snowpack, which is kind of trying to replace a lot of the headaches around that, and it uses the ActionScript module system. So if anyone's interested, check Snowpack out. It's very, very cool.
Okay, I should look into that too. Yeah.
So cool. Great stuff. All right, so folks, we're going to drop in. There is a Zoom link going in now. Mary, I'll drop one of those in the Zoom thing here.
Okay. Yeah.
So that's the Zoom chat for some live Q&A. Please, folks, swing by there. Say hello to Mary if you've got any questions on any of that stuff. Mary, thank you very much for tuning in and joining us here at Build Stuff. It's been a great pleasure. Folks, we're going to take a short break. We'll be back on here on Jupiter, stage 4, with our next session in about 10 minutes. Thank you for tuning in, folks. Have a good break. Stretch your legs. Get away from your desks. We'll see you shortly. Bye-bye.
Thanks. Bye-bye.